Welcome. Today we will learn how to deal with longer UDL using ILD concept. So let us consider a beam or girder of 30 meter span. Okay. So I have a girder of 30 meter span. Now imagine there is a UDL which is longer than the span, which means the length of UDL or the span of UDL more than 30 meters. Okay, so I'll just break this UDL here. So which means you need to imagine that this span is more than 30 meters. Okay, let us say load value is 10 kilonewton per meter. Okay, now if this particular UDL is traveling from either from left to right or from right to left, okay, whichever may be the case. Right, my interest is to find reaction at A, reaction at B using the ILD concept. Okay, so while traveling this, the UDL, while it is traveling on this span, it is going to cross this span as the span of the load is more than 30 meters. So it can occupy the full span, right? So now my interest is, let us say I'll start from reaction at A. So how to calculate reaction at A that can occur due to the UDL longer than the span. So first I need to draw ILD for reaction at A. Okay, so I will be drawing first ILD for reaction at A. So 1 unit at A, 0 at B. This is ILD for influence line diagram for reaction at A when 1 unit load is passing on this span AB. Now instead of 1 unit you have a load of 10 kilonewton per meter, which is more than this 30 meter span is traveling on this AB. Okay, so while it travels, when the head reaches B, there will be still some more UDL left behind A, so which means the UDL can occupy the whole span. Okay, so now if the UDL occupies whole span, so it is occupying the whole area of this ILD. Okay, so now I'll draw the UDL also, which takes the position something like this. Now you can see the UDL is longer, right, than the span. So load value is 10 kilonewton per meter. Now to get the quantity of reaction when there is UDL on the span, you need to multiply the load value with the area occupied by that load of ILD for that particular quantity. Okay, so load multiplied by area of ILD occupied by UDL. Load value is 10. Okay, area of ILD is a triangle. ILD is a triangle, so area of triangle half into base, it is complete 30 meters it is occupying, so base is 30. Height of ILD is 1. Okay, so now this 2 goes here for 15. 150 kilonewtons is the maximum reaction that can occur at A. Okay, maximum reaction, right? So for all other positions of load, the reaction at A will be lesser value. Similarly, you want RB, right? Let us say would like to calculate RB also. Try draw ILD for RB. So influence line diagram for reaction at B is 1 unit at B, 0 at A. So another triangle will come, and this is ILD for RB. Okay. Now if I want RB value, similar calculation, you see the load is occupying the whole area of this triangle. This, you can drop this here. So these ends of loads are beyond the span. So total span is occupied by the UDL. Similarly, the ILD of RB. Load value, applying the same formula, load value multiplied by area occupied by UDL. Area of what? Area of ILD. Okay. So influence line diagram area is again half into base into height. Base is again same 30 meters of UDL here. Okay, so same span of the beam itself is the span of the ILD, right? So this will be 150 again. So now if you see, if you can add these two loads, total load value is the RA plus RB is 300 kilonewton. Now you see what is the load on span acting. 30 is the span, UDL value 10, which is equal to 300 kilonewton. So total load is shared equally by the two supports. So this we know already by the equilibrium concept. Again it is proved by the ILD concept. So this is how you need to deal with longer UDL to find support reactions. Okay, right, we'll be back with the other calculations like shear force and bending moment.